Okay, guys, welcome again. So let's start with a prayer. Brad, can you say the prayer?
Yeah, absolutely.
Thank you.
Our Heavenly Father, we're thankful for this evening. Thankful that we're able to meet together for this group, and ask you to please help us to be directed by thee and guided that this information we're going over will be relevant and that it will be effective and that our learning will be effective, that we will be able to perform well in this class. We thank thee for all that we have, the opportunity we have to help us to do so together. We say these things in the name of thy Son, Jesus Christ. Amen.
Amen. Okay, so let's go on the quest. Do you have questions about this lesson? Specific questions or a difficult exercise that you found it? Feel good, Josh?
I don't feel great about it, but I mean, I was able to look at it and try to figure out the best I can. I was looking at the quiz, so we'll see how it goes with the quiz. But yeah, I'm not sure.
Okay, so let's see. Okay, so are you in the quiz now? Question number 3.
Yep.
So the total area under a normal distribution curve must equal, but first we have what you're requiring information to work together in the quiz, or if you need here on the. Do you have that app? Did you download?
The link.
The normal probability applet.
Yeah.
Okay. So question number 3 say the total area under a normal distribution curve must equal 1, right?
So do you guys have a graph on that, or are we supposed to just use that normal probability thing, the link? Does that make sense?
Sorry, I can hear you well.
So do you guys is there a chart underneath question 3? Because all I have is the total area under a normal distribution curve must equal, and then your answer. But what are we going off of? Is it?
Yeah, I think it's talking about a general information. So it's when you have a distribution curve, it must equal 1.
Okay, I didn't know if I was missing a link or a graph or something. So.
If you want, you can click on normal probability applet, and you can see the area when you click on the curve, in the upper part, the 1.
Okay.
Are you agree, Brad?
Yeah, I'm still looking at it.
So let me see if I can share my screen. You're talking about this right here, right?
Exactly. So if you see in the upper part, you say 1, right?
Yeah. Let me click them off.
That is the total area.
Okay.
Of distribution curve.
Okay, but you don't have on question 3, yours looks like that, right?
Exactly. Yes, I have that one.
Good. All right. So I'm doing good.
Perfect.
Yeah, I agree with that. It equals 1. Yeah.
Okay.
Okay. Perfect.
So question 4: under certain circumstances, normal distribution curve can drop below the x-axis.
I think it's false because all the distribution curve are on the x-axis.
Mm-hmm.
It's got to be on or above, right?
Yeah.
Yeah.
I don't remember reading anything or anything in the videos that showed anything below it, so I would agree with that.
So, do you feel comfortable, Brad, with false? Okay.
Yeah, that's what I.
Okay, yes, it's false. So.
All right,
Okay.
am I up?
Yep.
Okay. Normal distribution curve is symmetric. True or false? It
Good question. I didn't know.
has to be symmetric.
Well, when they use those bar graphs, they just put the line above it. But I mean, there is. I don't know. I don't know about that either.
I think it could be a symmetric because it's a what's the name? A bell shape.
Because it can.
So if you see in the lesson about the distribution 66, 95, and 99.7%. So I think that is the symmetric part, but I don't know. I didn't read this
Okay.
part. Yes, you feel comfortable with
Yeah,
that?
I see. Yeah, it looks like it is going to be. If it's normal distribution, then it should be symmetric. Yeah.
Okay, perfect.
And I found in the reading, just looking for that answer, in the reading it does say it has to be above the horizontal axis on that other question. So
Yeah. I think I got that one.
Okay. Okay.
so
So,
you're saying number 5 is true though, right? It can be symmetric. It's true.
Yeah. Yeah.
Okay.
Okay. So next question. Use the following image to answer the next two questions. Okay. So we have the graphic. Which of the following elements of the figure represent the z-score? Oh. The A, right?
So isn't it A or B? Like isn't it? No.
So I think
I
it's
don't think
A.
it would be A because A is including the center.
Yeah, so it's B then, because it's not including. I'm trying to
What
look
do
at.
you think, Ronald?
I'm remembering. I think it doesn't matter if you include the center because if you write the z-score on the bottom of the page in the left part and the minus one, so that determines the z-score because you take part of B when you're talking about z-score. So, sorry, let me find the answer in the textbooks. Uh, 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 uh. Z-score. Okay. Okay. If you go on the textbook in the part of the converting a z-score to a probability. Okay.
What section?
3.2.
3.2.
Okay, I think is the letter A because you need to um, click on the area that you want to find, if right or left, to find the C score. Because if you don't have if you don't select that one, it's not the C score, I think. But I don't know.
Trying to figure it out.
Because you see in the 3.2.2 basis average. Are you there?
Yep.
So if you can see, you only have select one part of the curve, right?
Uh-huh.
The right part.
Yeah.
So is you read the down part side, the part below, the area under the curve to the right of Z equal 0.559. Because the Z score is only the selected part.
So
Does
you're
make
saying
sense?
it is B then, or what are you saying it is?
The letter A, but I don't know. Did you find a different thing, Brad?
Yeah, I'm not. No.
Oh, sorry. I think it's letter C. Because if you select the letter A and the letter B, is the area. It's not the C score, right?
That
Yeah?
makes sense. Okay.
Perfect. It's letter B, sorry.
So you're saying it's letter B.
Yeah, letter C. C.
C,
Because
because
Letter
it's
C. Yeah.
C.
below with the number.
Yeah. Letter C
Yeah,
is what's actually representing the C score. Letter A is representing the percent.
exactly.
Um,
Yeah, sorry.
that makes a lot more sense.
Perfect.
So 7 says, which of the following elements of the figure represent the probability that the z-score will be greater than 1.000? Around, yeah, same thing. So none of them, right? Because
I think it's no. None
it's
of these
none
represent,
of them
right?
because it starts at 1 on B, right? So everything above to the right on B would be above 1.
This is what it's asking, right?
Yeah, so
It's saying what is the probability that Z score will be greater than 1? It would be the area of B.
yeah, right?
Yeah, so if we go to that little applet that
Yeah.
beginning of the assignment, B is the area that we're looking for. That's going to be the percentage of everything greater than the Z score of 1.000.
So
Thinking, Josh?
what's that?
Is that what you were thinking? Was B?
Yeah, just because it's above, it starts
Okay.
at 1. I mean, according to the z score below it, it's 1 right there, and so everything to the right would be above 1. Is that right?
Yeah.
That's what I understood. I was looking back at the
Yeah.
reading real fast, but
That's what makes sense to me.
because that would be greater than 1, so B would be the answer. I was just checking at the reading real fast. Anyways, we got 2 tries, right? So we'll know.
I'm trying to look for it. I'm not sure.
Are you guys good to move on to 8? Or are you still waiting, Ronald?
I'm okay with moving on. I think we'd be
Okay.
able to figure out if we missed it.
Yeah.
I'll just put a note.
Number 8 says, according to the 6895 99.7 rule, data from a bell-shaped distribution will be within 1 standard deviation of the mean. It's going to be 68, right? 68 is within 1 standard deviation, 95 is 2, and 99.7 is 3. Right?
Yeah. I agree.
I remember that.
68?
Yep.
Who wants this one? I can read it. Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What is the proportion of the z-score? Will it be between -1 and 1? Give your answer as a decimal accurate to 3 decimal places. If the answer was 0.389184, you would enter, you got it. So we got to use that applet.
Yeah, it's 0.683 if you close the last part. 0.683. If did you do?
So you selected, so you're using the applet, you selected the
center of the graphic.
Gotcha.
And did you put z-score -1 or 1, whatever you want, and then you have the area in the upper. Yeah.
Top.
Yep.
So.
Okay. So it's 0.683 or 27. Oh yeah, it's we need to round, right? So CX3. Okay. My turn. Question 10. Suppose the z-score come from standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between means 2 and 2? Where is 2? 0.955. Do you have?
How did you
Perfect.
Josh, is that what you got?
So how did you guys do that? I was trying to figure that one out.
Okay.
What I did was just under that normal probability applet.
Yeah.
Bottom is -2.000 or calculate the area under the curve at 90.9545.
Oh, cool. Okay. Yeah, no, I got that figured out. I'm just trying it right now.
Okay.
Okay. Perfect.
All right, so I'll do the next one. I'm just changing those numbers to 3.
Yep.
997, right?
Yep.
0.997.
Yep. Do you have that, Josh?
Okay, so question 12. It says, look carefully at your answers to the last 3 questions. What do you observe? option A is the values match the 68, 95, 99.7 rule. As the z-score increases, the area between negative z and z increases. The probability doubles as you move from z1 to z2.
This is the first one, right? The value matched the 68, 95, and 99.7 rule. What do you think?
Yeah, that's what I got too.
Okay.
Because it was definitely following it.
Okay.
I can read the next one. The amount of protein that an individual must consume is different for every person. There is solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein each day per kilogram body of weight times kilograms. Let's see, is that what that is? The population mean protein requirement for adults times kilograms times D, and the population standard deviation is 0.07. The population has a protein requirement that is less than 0.60.
So we need to look for the formula, right? So I think it's 0.66 minus 0.60 divide 0.07, right? That's the formula. Or we are going to have the proportion. Does this make sense?
Yeah, let me just try something real fast.
I have 0.857 like answer, but I don't know if you have something different.
So you took to figure out your answer, you took 0.66 minus 0.60
Yeah.
divided by 0.07,
Yeah.
and that comes out. Let me try to figure.
That is the z-score formula. In other words, is the mean. Oh, it's not 66, 65, right? Sorry. The mean is 0.65 minus 0.60. That is the protein requirement, and divide 0.07. Oh, it's 741. 714. So I think it's that answer. So yeah, guys, do you have another different answer?
Not sure on that. I don't know what to.
So what did you get, Ronald? For yours?
0.714.
Yeah, that's what I was getting to. On that formula that was in the text, right?
Yeah, and the videos. This is the Z-score. You can calculate the proportion from the Z-score formula. And you almost use that formula and everything in this unit. Do you have that, Josh?
Yeah.
Okay. Questions? No?
No.
Okay. Next exercise. Question 14. What proportion of the population have a protein requirement that is more than 0.60 grams per time kilogram density? Give your answer accurate to 3 decimals. More than. Huh. Protein requirement.
Okay, so I did this a little bit different. I put our number, our 0.714 ability applet. Put that in as the Z-score, 0.714. A different area. Area to the left of the curve is everyone is 0.238, which makes more sense because that's the amount of people that are below the mean should be less than 50%, right?
Yeah.
You want to share your screen?
Yeah.
0.714.
See that?
Yep, I can.
Okay, so if we change the Z-score to 0.714, which is what we calculated the Z-score to be, that doesn't actually represent the percentage of people, the Z-score. And so we can based on that Z-score, people are below that or above that Z-score. So we can say 24% of everyone's going to less than 60 grams of protein per kilogram based on their body type, which makes more sense because if the average is 65, this right here would be the center, 5. And so it wouldn't be 71% of the population wouldn't have, going to be less than that. It's going to be less than 50% of people are going to be less than the mean. Does that make sense?
Yeah, so
Our answer is this area, the 0.238.
8. Okay, guess you got it.
0.238.
I feel comfortable with that. Yeah.
That makes sense. 0.238.
And so for number 14, what proportion of the population have a protein requirement that is more than 60 is going to be, just a second. More than 60 is going to be everything greater than the 0.714, which is going to be 76.762. And does that make sense to you guys?
No, that does make sense. And I'm glad you shared your screen because that helped me out as you explained it.
Okay. I sure hope that's right.
And so then in question 15, it's saying, because we're on 15, right? Is everybody there?
Yep.
Okay, so 15 says, what is the proportion of the population that have a protein requirement that is less than, so going back to that chart,
So now you need to select all the curve, maybe? Something like that.
So everything's to the left of the z-score, the positive 0.714 z-score, right?
Less.
Because that would be the 0.7, because 0.65 is the center, and we did 0.60. I just did the math again just to make sure, but that's the same for the z-score for 0.70 is just like we had there. Left of the curve, which is the same, 7.762. Right?
Yep.
So 16. The probability that a randomly selected person will have a protein requirement that is between 0.60 and 0.70. Hint, remember that to find the area between the two values, shade to the left of each z-score you calculate and then subtract the smaller area from the larger area. Make sure your answer is positive. This is the probability that a randomly selected observation will lie between the two values.
So that question is in the 3.3 on the textbook. Find the probability of being between two values. Do you find it, Josh?
Yeah, oh yeah, yeah.
So the answer would be the first value is 60, right? Okay.
So this is how I don't know if I'm thinking the right way. So you take 0.70 minus 0.60, correct?
Yeah.
Because in the 3.31 of the reading, they're talking about height of a person. They take the difference between the two values. Is that sounding correct, Brad, or is that way off from what you're doing?
No. So I'm doing the same thing, but instead of using 0.60, I'm using 0.65 because 0.65. So you get the z-score for 0.70, which is 0.70 minus 0.65 divided by 0, and that gives you the z-score for 0.70. And then you do the same thing for 0.60 minus divided by 0.07, and that'll give you z-score for 6 for that one. Yeah, between those, which should be. Did you guys get an answer for that yet?
No.
Oh, it looks to me like it should be 0.525. Kind of like double checking to make sure I'm not doing this wrong, because our two numbers, our two questions are even. They're both the same z-score. One's a positive, one's a negative z-score.
Yeah.
That we have. We can go to that normal probability applet, and it's just the center area, because that area is literally between those two z-scores. So it's, if you're asking for the probability, we lost Josh. Oh no.
So
The probability there.
0.12. Yeah, so if you select the center of the area, we have a 0.523, right? Or 4, we can put it. So that's the answer. Do you think that's the answer? I feel comfortable with that.
Yeah, I think it was, my answer was 0.525.
525. Okay.
Yeah, what did you put for your z-score? 0.714? Is that what you put for your z-score, Ronald?
Yeah. Oh no, sorry. I put. Okay, now I have the same area. Perfect.
Okay, good. Yeah, I think I feel good about that because I did it the other way too, and it looked like it checked out.
Yeah.
Should
Okay,
be it, but I wanted to make sure.
Okay.
I think we'll probably wait for Josh. I don't know if he'll log back in or not.
Yes. Yeah. Let's wait for a minute. We have 2 questions left.
Yeah. All right, we could probably get started, and that way when he logs back in, we can just kind of tell him what we've come up with.
Okay. So find the 35th percentile for the pertain requirement for adults. Write your answers to 3 decimal places. I don't remember that part. Do you remember?
Okay. Let's do this.
I think I heard that, but I don't remember. Let's see in the book. Okay, it's calculated percentiles. 25th is the grade. Are they equal?
The text 3.4.
Yep. So
okay,
what is our z-score? It's the same.
That's what I'm looking at right now.
So it's the next six questions. So it's 113, 214, 315, 416. Oh, this is the same Z-score. So we can use 0.714, right?
Yeah.
I don't know why I thought I could save you. You would keep everyone safe like you did, Dad. Everyone now.
So I'm trying to figure out the answer according to the textbooks, and the textbook example said that the 0.900 in the area is the ninth percentile, right? So if we put the Z-score on the normal probability applet in the Z-score 0.714, we have the area 0.762. Maybe this is the 17th percentile or 25 percentile. If we divide in two, that could have the answer. But I don't know if it's that correct. First 50.
Do you want to work it out? I'll try to work it out too, and we'll see. I'm hoping Josh logs back in so we can go over the last couple questions.
Yeah. I don't know if we need to use the QQ plot. It's a difficult one.
Yeah.
Hmm.
Okay, I'm figuring it out. Sorry, it's taking me forever.
Don't worry. I'm
I think-
trying, but I can't.
I've got an idea.
So,
Sorry. All right, Ronald. I've got a potential answer for us. All right. Are you ready? Are you there, Ronald?
Now, did you read the jazz music?
I couldn't read it. No, I had it pop up on my phone though.
Yeah.
Right
He's
now.
trying to connect.
That stinks.
Yeah. So we can say
Always just send him.
the
We
answer.
can send him
Right?
those answers. Well, do you want to send him? I think we decided that we were on 16, right? So we decided the answer for 16. I'll send it to him.
Yep.
16 was point. And then we got 17. Figured out 17 is going to be 0.062. With you, how I did that. So you can tell me if you think I'm right or not. So what I did was I took the 35th percentile and I plugged it into. Let me show you this. I'm going to share my screen with you real quick. Okay, Ronald?
Okay.
Just a second. Just a second. Okay, here we go.
Okay.
Let's do that one. All right. Here, are you ready?
Yep.
0.350, which is the 35%, right?
Okay.
Score right here, which is 0.385.
Okay.
So if we take that number and that's our z-score, and if we go into this formula right here, where is it? This formula right here. Can you see it?
Yep.
Where z equals x minus the mean over the standard deviation. And then to say, okay, z is 0.085 or whatever that number was, whatever this number is, 0.385 equals x minus the mean, which is 0.65, all of that divided by 0.07.
Yeah.
And then if we work that out and solve for x, I got 0.062. And so what we're saying there is the protein requirements for adults. Okay, wait. I don't think is that the finish? Sorry, I can turn off my screen share now. Okay.
It is your answer, but I divide and it's 0.623, no 0.062.
Oh.
Can you try again?
Okay, so we did, negative 0.385.
Yeah.
Because it's a negative, right?
Yeah.
Times 0.07.
Or we can try with the positive.
With positive, I think it'd make a difference if we did the positive. Let me show you what I'm thinking. The positive is essentially what we're saying is we're saying this. We're saying 65% is going to be the positive because this is the positive scores, everything less than that.
Okay, I understand.
Negative 0.385 to get this number, this shaded value, because otherwise we're looking at 65%.
Yeah. .385
Okay.
Times 0.07 equal plus 0.65. Yeah. Look. Can you see the answer?
Yeah. I got the same thing as you. 0.623, which makes more sense. Mine was, that makes much more sense than mine.
Perfect.
0.0623, right?
Yep.
I'm putting this in so that we can send it to Josh. 63. Okay. I think if we use that, let's change.
Yes.
0.623, right?
Yep.
Okay. So now if we do the same thing and we change to 80, now we've got a 0.842. That's a positive. 0.8. Or we do x minus 0.65.
Positive.
07. Right? Yeah, it's going to be a positive 0.842.
Okay.
0.842 times 0.07
plus
add
0.65 is 0.709. Yeah.
Okay, that's what I got.
709, right?
Okay. Well, let's submit those, and then I'll
Yes.
be 0.709. Okay.
So.
Okay, I'll submit it, and we can see if we got them right. How's that sound?
Yes, we can see it together.
Okay.
Yes, 2020.
Sweet.
Pretty sweet. Woohoo!
That was freaking
That's
intense.
pretty good. I mean,
It should have been.
yeah.
All right.
Okay,
Okay,
so
glad we got them all right.
are you going to send it? Did you send? Okay, it's okay.
Did you see it?
Yep. Perfect.
That's it, okay.
So, thank you.
Are you gonna submit this again? I'll comment on there again.
Yeah, I'm going to submit it. Don't worry.
Okay. Right on, Ronald. Well, thanks a lot, man.
Yeah.
We
you
will
too.
see you on
See
Tuesday
on
at
Tuesday.
8, right?
Yeah.
All right, sounds good. Thanks, man.
Bye. Bye.